Okay, we're going to insert general notes again. We're going to talk about some slight differences from ANSI versus ASME. So I've left this up there so you can compare. I'm going to copy this general note in. And we've got to go back to the edit background. Go into annotation and select the text. Click a location and then paste that in there. Whoa. That's weird. Let me see. Why did it do that? Now, for some reason, it gives me another line. I'll try and get rid of that line. Click. Dang it. I'm going to try. I'll move this box up because, again, I see it better here. I'm going to click on where it says D and hit Shift Enter. Select OK. Alright, so now I've got my general notes here. You'll notice that, unless otherwise specified, tolerance is plus or minus 30. Well, with a lot, but not all, ASME drawings, they went to 4-place dimensioning. So, if I zoom over here, and we go back to the sheet background, and I click on these, click on this and go to let's see if I can do this. Let's highlight all of this, right click, properties, and I'm going to change the decimal factor to 4 places on all of those. When I hit apply and say OK, one thing is when you're doing 4 places, you'll have to change the spacing of this. Again, you click on this, right click, properties. Because it went to 4 places, it got the system too tight. We'll have to do something like 9/16. No. 9/16, 10/16. We'll try 5/8 via 0.625. I'll do 5 divided by, no, won't do it in this one. 0.5625. Okay, give me a little more spacing here. So for the ASME specs, you notice it says plus or minus 30 thou. Over here, even though this is 4 places, when you call this off in the general note, we remove this from the tolerance block. If this tolerance block isn't removed, that means that all those dimensions have to hold to 0.0005, 5,000ths of an inch. Well, that is going to be one expensive part. So you don't want to do that. So you might wonder, well, why would you go 4 places? Let's go to the sketch. The best way to do that is to right click on this and open the 3D data to make sure I'm going specifically to the correct part that was used for that drawing. I'm going to double click the sketch. Let's make this 6 plus 0.375. Let's make this 4 plus 1/16. let's make this 2 plus 5/8. Okay, so now that these dimensions are changed, we can exit out. The part is automatically update to reflect that. Had I had my measurements showing, you would see these measurements. Whoops, measure item. The part has changed accordingly. Okay, so I'm going to get different lengths for these because of all the adjustments I made. All right, so that automatically was changed in the part. Now when I come to the drawing, I'm going to get an update feature. See all these little yellow marks in the specification tree on the top left corner? All those little yellow circles on there? That's an update. You can hit this update down here in the feature on the bottom, or you can right click on the top collector and hit the update there in the contextual menu. Either way, you'll get the same results. When I hit update, you'll notice the dimensions will change to reflect the numbers that have been edited in the part. That's one of the beautiful things about CAD. It does take longer sometimes to make a part, but your ability to modify is so much easier than doing it on paper and pencil. All right, now the reason why a lot of the companies switch to going 4-place dimensioning and using this call out here is so there's no controversy on what size I really meant to go with. So if I change these back to 2-place constraints, go to right click and go to properties. If I go to value and put this back to 30 thou and hit apply, or 2-place precision and hit apply and say okay. Yeah, all these 1, 2, 3, that's all fine, but when you get over here, these numbers look odd. And when I see these numbers, because I've been in production so long, I just know that these are 3/8, 1/16, 5/8, okay? Because I know what that would round up to. So this is rounding up, but in production, you want to know that these are actually going to fractions. Well, to remove that question as to whether or not it's 638 or is this 6375, they decided to leave these all 4-place dimensions. So I just hit undo to put it back to 4-place dimensions. This being 4-place dimensions, we don't want that tolerance. What we're saying is, unless otherwise specified, it's all going to be 30 thou tolerance. So we've got to get back into the background. All this hard work I did putting this in, I'm now going to delete it. And I'm just getting those lines, because remember it was a rectangle is what I did. I probably should have just created 2 lines, but I just created a rectangle real quick. Okay, we'll go edit sheet. Now, unless otherwise specified, I'm at 30 thou. Now maybe this dimension I need to hold the tighter tolerance. So what you would do is you would click on this, right click, and go to properties. I'm looking for a tab called tolerance. And I'm going to pick let's just pick the first one here. Wait a minute. well, you know what you can do? You just can always experiment with that. I'm going to go 0.010 and hit tab and change that lower value to 0.010 and hit tab and hit apply. Okay, so with this style of dimension, this is what you get. I want to hit a negative on the lower tolerance, hit apply. So if I do plus or minus and they're the same value, it'll automatically change it to this style here. So when I select OK, what we're saying here is all these dimensions are 30 thousandths except for where it's saying here, unless otherwise specified, I have specified a different tolerance on this one to be plus or minus 10 thou. Alright, so that's kind of the general difference. When you do the ANSI drawings here, we're going to go 2 place dimensions. If you see ASME call out, I'm going to do 4 place dimension. The ASME call out, we're going to say unless otherwise specified in the general note. See tolerance block, when using ANSI spec, we're going to create that tolerance block I just deleted. Alright, so that's the 2 different ways we're going to insert general notes. Again, this drafting here per ASME specs, maybe you can do a free download or go search for this. This is what that book looks like. There's your ASME specs. Okay, and if you're going into the engineering tech field, you should probably have a copy of this book. If I'm not mistaken, I think I made that a requirement, if not at least a recommendation to buy this book for the drafting class, because you're going into this field. I think everybody actually should have to pull up this book so that you have all the specs for all the standards. Deburr and break all sharp edges was talked about in the previous video. Again, we're just breaking off all the sharp edges on the aluminum so you don't drag your finger across the sharp edge and cut yourself. Alright, and then we're building the part as pictured. That allows, if I made a mistake and didn't dimension something, or there are no dimensions at all on it, you're asking the shop to create their measurements for themselves, find it on the 3D dataset using the measure command. A lot of times these days we actually take the actual 3D model and then machine right to the 3D model. So if you're doing that, you can use this note here. Alright, so just wanted to go over the 2 different types of notes. General notes for ANSI or ASME, the differences there.